Okay, so please go to this website and then enter this game pin here into Kahoot. And we are going to go through a few questions before we get started. Five of you. Anyone else? Okay, I'm expecting 16. Anyone? If no, then I think I will get started. 9. Okay, so I will start the Kahoot and you can join later if you still loading the site. Okay, descriptive statistics, that is the topic for today, but first let's answer a few questions about last time. So first question is, what do we do in statistics? Okay, good. So last time I told you that the statistics basically means you try to collect data and then you try to summarize the data because you want to extract something useful from the data. And finally, you draw conclusion about the data. So that means everything, not just collect the data, but also summarize and draw conclusion from the data. So the green one is the answer. The next one. Okay, so to collect data from a sample and draw conclusions about the sample only, we use which type of statistics? This one should be simple. Yes, that's correct. Because we are just trying to describe what we have in the sample, and we are not trying to do any inference to make a guess about anything bigger than the sample. So this is just descriptive statistics. Okay, the next one. So which of the following is a non-random sampling? Last time I talked about random and non-random sampling. I also gave you some examples. So which of these are non-random sampling? So this one is more controversial. So the red one, asking your friend to distribute your questionnaire. So remember that random sampling means that everyone in the population has the same probability of being selected. And non-random sampling means at least some of them have a different probability of being selected. So suppose that you are just distributing your questionnaire to your friend and ask your friend to distribute your questionnaire to their friends. Now, in this case, if someone does not know you and also does not know your friend and or does not know your friend's friend and so forth, then these people have basically a very small probability of getting your questionnaire. So it means that the probability that they will be selected is less than or smaller than the probability of your friends being selected. So the red one is a non-random sampling. Now the blue one, posting your questionnaire on the Facebook. Now this is basically a digital version of the red one. Basically, it is the same except that you are not passing your questionnaire over to other people, but just passing the link of your questionnaire to other people. So the blue one is also a non-random sampling. Now the yellow one, interviewing a group of experienced accountants. Remember last time I said that when you do interview, you do not just pick anyone by random. Instead, you pick someone that you think will give you the understanding of the topic. So it means that you intentionally select those people and invite them to your interview. Now, in this case, it is also non-random sampling. But in this case, the non-random sampling is actually a good thing because that is what we do in qualitative study, as I mentioned last time. Okay, so the answer is all of the above. By the way, last time at the end of the class, I have put the video recording onto a YouTube playlist, as you can see in the chat room here. At the end of today's class, I will post this link again, so you can, just in case you are not sure about what I taught last time, or you did not attend the class last time, you can always refer back to the online video recordings, okay? So the next one. Okay, the error in data collection can be caused by which of the following? This one is pretty straightforward, yes. So the red one, non-random sampling, of course, it can introduce error into the data collection because you are doing, basically you are introducing bias into your data. So that is a very important type of error that we have to keep in mind when we collect data. Now, the errors in data entry, of course, this is also pretty common. Now, the yellow one, exclusion of some items from the population. Now, even though you might be doing a random sampling, by definition, when you draw a sample, it means that you are ignoring some individuals in the population. Let's say you have, the population has like 10,000 people, and you only select a sample of 100 people, then everyone who are not selected will be excluded. And also, no matter what they think about a certain topic, their thought will not enter into your data. So this is also a type of error. But of course, this type of error is something that we cannot avoid if we are going to do sampling. So all of the above. Very good. Okay, Alex is still here. Okay, which of the following is an example of ordinal data? So last time I talked about the different levels of measurement, and ordinal data is one of them. So which one is ordinal data? And pay attention to the difference between the red one and the blue one. They are not the same thing. Okay, so that the red one, the age means that I just ask you your age and you give me a number like a 28, 29 or 19 and so forth. So this number is certainly something that that is something that we can calculate the average of the age. So the age itself, this one is a scale level of measurement. Scale means number, but the age group is not a number. The age group is a range of number, like 25 to 29. You do not just give a single number to represent your age. You give me a range of numbers. Now, in that case, it is really difficult for me to calculate the average age because I don't know your exact age. I just have the range of age, the age range which you belong to. So in this case, the age group, these are the groups, these are categories, but there is a particular order in which I must arrange these age groups. So in this case, this is ordinal. Now, nationality is not ordinal. Of course, this is categorical, but there is no particular order that you must arrange the nationality options in your questionnaire. So the nationality here is actually nominal data. And the exam score, here I mean the number, like you get 98 marks in your exam and other student gets 70 marks in the exam. So this is also a number, and this number is a scale level of measurement. So the answer here is the blue one. The age group is an ordinal level. Okay, this is the last question before the lecture. So Likert scale belongs to which of the levels of measurement? I guess this one should be easy because I just mentioned this last time during the lecture and actually emphasize it a number of times. So, okay, now the Likert scale. Now, when we ask people to give me an option out of 5 options, and those 5 options are, in this case, they are strongly disagree, and then disagree, neutral, agree, and then strongly agree. So these are 5 categories that I ask people to choose from. And these categories, of course, there is a particular order in these categories, but they are still categories. Now, so in this sense, the Likert scale is ordinal, but not the scale. Now, this is a very common mistake by many people, even though for those people who are researchers and who submit their articles to the academic journals, many of them still make this mistake. Likert scale is ordinal data, but not the scale data. So the number 1 here, number 1, 2, 3, 4, 5, the numbers here are just labels and they do not represent anything that you can calculate. So, but what if you really want to collect data in the form of scale level in this case? Now, in that case, you have to adjust your questions a little bit. So instead of asking people how much they agree with a statement, instead of asking them to choose from strongly disagree, and so forth, you ask them to rate a number. Like you ask them to rate a number from 1 to 5, okay, and to represent how much they agree with a statement. So if they agree with it very much, they can give a number larger, like give a 4 or give a 5 and so forth. Or if they do not really agree with it, they can choose a smaller number. Now, in this case, you explicitly ask them to give a number rather than to choose from one option from 5 of the options here. In this case, it is scale level data. Okay, so please be very careful about this. If what you really want is something that you can calculate the average, the standard deviation, and so forth, then you ask them for score, but not for Likert scale. Okay, please be very careful about that. So the Likert scale here is ordinal and not the scale. Okay, so at this point, we have gone through a few questions that from the last time. And now please put this browser tab aside, and we will come back to this later after the lecture. All right. So any question you want to ask about the revision here? If you have any questions, please type it in the chat room, and then I will answer that first before going into the lecture. No? Okay, if not, then please go to the website. Okay. No, okay. So at this point, please go to the website, and this time we are going to talk about the second topic, which is descriptive statistics. So again, I will go through a lecture first, and in the lecture, I am going to tell you exactly what we mean by descriptive statistics. So I will talk about the concepts of descriptive statistics, and also I will talk about the specific ways that you can use to do the descriptive statistics. And pay attention here that, again, as I told you last time, the method that you can use in statistics depends on the level of measurement of your data. So today I am going to tell you how to do the descriptive statistics for scale data, that means numerical data, and then I will talk about the descriptive statistics for categorical data, which means nominal and ordinal data. Okay, and then I will give you some I tell you how to do it, actually do it in SPSS. That will be the second part of today's session. And then I will also show you how to do graphing in SPSS. That is also very important. And finally, I tell you how to export the SPSS outputs. Last time, one of you at the end of the class, you asked me how to save the data and save the output. And I told you that you have to save these two in two separate files. So that is very important. And today I am going to talk more about how you can export your SPSS outputs. Okay, so please scroll down to activity 2.1. And here you should find this link. This is the lecture notes on descriptive statistics. Now, please open this file on your computer, and I will go through it with you together. So if you are ready with that, please raise your hand in Microsoft Teams so that I know, so that I can get started. Okay, how about others? Okay, let's move on. Now, descriptive statistics. Now, first of all, let's look at the central tendency, the concept of central tendency. Now, central tendency basically means I want to know where the data are, Now, but notice that there are different ways to find the central tendency of the data, but they do not apply to all of the levels of measurement. Now, in this session, I am going to talk about 3 of them, and I'm sure that you are already familiar with some of these at least. So the mean value means the average value, 平均值. So the average value is only for scale level data. And then we have the median. Median, by definition, it means the number in the middle, or in Chinese, we call it 中位数. So the median can be found for the scale level of measurement, but it can also be found for ordinal level. And the last one, the mode. can be found for all the 3 levels of measurements, although it is more common in some of them and not the others. Now, at this point, I want you to look at these 2 example data sets. Now, on this page, you see data sets A and B. So let's suppose that they are the examination scores of 2 groups of students. So group A is at the top here. We have 40 students. That is the sample size. And all the 40 numbers are given here in this table. And down here, we have another group of students, and that is group B student with the same sample size but different scores. Now, on the right-hand side, we have the histogram of the data. The histogram means that basically we divide the number line into different groups, and then we count how many people fall into each of the groups or each of the intervals. So in this example here on the right-hand side, for group A, we have 20 to 40. 20 to 40 actually means 20 to less than 40 in this case. And then we count how many students fall into this interval. So we look at the data here. We have 30 here. 30 is, of course, between 20 and 40. And then we have 35, which is also between 20 and 40. But the third one is already in another interval. So we draw a bar here or a column here, which has a height of 2. And then we have 11 students between 40 and 60, 21 between 60 and 80, and 6 of them between 80 and 100. Now, the same is true for the histogram in the student group B. Now, I want to ask you one simple question. Now, you look at the histogram of A and B. Can you tell me the main difference between the score distribution in A and B? Can you give me some ideas in the chat room? The difference, the main difference between the examination scores of these 2 groups of students. How would you describe the difference? Any ideas? Okay, for A, from 20 to 200, sorry, what do you mean by 200? Okay, 20 to 100. And for group B, we are from 0 to 80. So you are talking about the range of the data. So for group A, basically, the scores go from 20 to 100. And for group B, the score go from 0 to 80. Yes, the range is different. Now, notice that the width of the range actually is the same. So from 20 to 100, there is a difference of 80. And then from 0 to 80, the difference is also 80. So the width of this range is the same. But the starting point and the end point are not the same. Okay, so this is one thing that we observe from these 2 histograms. Now, another one says that the majority of group A has 60 to 80. So here you are talking about the tallest column in the data. So I think you mean the tallest one here. Now, for group A, the tallest column is between 60 and 80. And in group B, the tallest column is between 40 and 60. Okay, so very good. Now, if I ask you which group of students is performing better, can you tell it from the histogram? Which one score better? Group A. Okay, how do you conclude? How do you draw that conclusion from the histogram? Yeah, if you are reporting this result, how can you report it using what you see in the histogram? Okay, one of you says that the mode of A is better. The mode here means that the most frequent group basically in the histogram, it means the tallest column. So for group A here, the mode is somewhere between 60 to 80, okay, because this is the tallest column. So the beta means that the scores corresponding to this column is higher than the scores corresponding to the corresponding column in the group B. Okay, so that is one way to describe it. You are using the mode to describe the difference between the two groups. Now, in this case, we say that, now, of course, you are not looking at all the numbers. You are just looking at the group with the highest frequency. Now, in this case, I would say that you are using the mode to represent the central tendency of your data. Now, to understand what I mean here, now let's consider the data even further. Now, of course, we know that the group A students are performing better than the group B students, but it doesn't mean that every student in group A is performing better than every student in group B. And the reason, of course, is obvious. In group A, we have someone who score only 30 marks and 34 marks. So these students, obviously, they score worse than many of the students in group B. So the difficulty here is that we are not just comparing two single numbers. We are comparing between two groups of numbers. And when you compare between two groups of numbers, you know, there are some smaller numbers in each group, and there are some larger numbers in each group. So it is really difficult to tell which group is better if you try to look at all the numbers together. But in statistics, we try to pick some of the numbers to represent the whole distribution. And those sum of the numbers usually is some type of midpoint or some type of center of that distribution. So for those of you who pick this one, the mode, you are using the tallest column to represent the center of the distribution. Okay, so that is one way to do the comparison. You compare the mode and see which one has a larger mode. And the one has the larger mode, and you say that that group is performing better. It doesn't mean that everyone in group A is performing better than everyone in group B. It just means that using some center or representative from the population, you compare the representative and then you draw this conclusion. Okay, so one of you also says that 27 students from group A scored 60 or above. Okay, so that means a 21 plus 6, while only 6 in group B scored 60 or above. So this is another way to do the central tendency. Instead of picking the highest column, you try to see how many people score a certain mark or above. Now, so this is also one way of doing the central tendency. Now, but there is one problem in this way. The problem is, now, of course, you look at the shape here, the two distributions, basically, they have the same shape. Okay, so you are just looking at, you are setting up some kind of boundary at the 60 marks here. And then you look at the right-hand side of the 60 marks and see how many of them score on the right-hand side of this. Now, of course, that is one way of doing that. But if you just look at here, look at everyone on the right-hand side of the 60, it means that you are ignoring everyone who are on the left-hand side of 60. Now, suppose that on the left-hand side of 60, suppose that some people's there are many people who score 40 to 60. So it's like something like this, a very tall column on the left of it, and another very tall column on the left of it here in group B. Now, in that case, the number of students who score 60 marks or higher might not be giving you very accurate idea about how well the students are performing, because most of the students might be on the other side. Okay, another one says that the median of A is in the class 60 to 80. Okay, so median, you mean the two numbers in the middle, right? And the median of B is in the class 40 to 60. So very good. Now that is another way to represent the central tendency of the distribution. But in this case, we, instead of just picking the group with the highest frequency, we try to order all the numbers, and then we try to pick the number or the numbers in the middle. Okay, so very good. Now, through this exercise, many of you, I think, already have some idea of what the central tendency is and why we need the central tendency. Now, but anyway, let's look at the lecture notes to learn about this from a more systematic perspective. Now, on page 5 here, now, again, you try to find some center of the distribution, because you are not comparing two numbers, but two groups of numbers. And then you cannot look at all the numbers. And so you have to pick some number to represent all the other numbers. And that is something called the center. So, but the problem is there is not a single way as there are actually multiple possible ways for you to pick the center from the distribution. Now, in this case here, for the center on the left, you are picking this because we have two groups on the left-hand side of this line and two other groups on the right-hand side of this line. So some people may say this is the center. But this does not seem to be a good choice in this case, because on the right-hand side of this center here, we have a very tall column. And you can see that if I add the two columns on the right, they add up and they are the majority of the distribution. So it seems that many people are here on the right-hand side of this line. And so this one does not really look like the center of the distribution. So some people may say, okay, how about we shift a little bit to the right-hand side to put another center here. Okay, so this center might be from the median or from the mode or from the mean and so forth. So people may use this center. Now, I don't really worry that you have problem calculating the mean or the mode or the median, because that is pretty easy mathematics. And you know, here you can simply go to SPSS, click on some buttons, and then it will give you all these numbers. So I don't worry that you cannot calculate these numbers. What I worry is that you don't know or you don't understand what these numbers mean, and you don't know that in some situations you should choose one of the numbers but not the others. And that is the main topic that I want to talk about in this part. Now let's look at the average or the mean. Now on the left-hand side, you see that some of the, actually all of the squares here are shaded. Okay, they are in black. It means that that number is used when you calculate the mean value here. So you know the mean value basically means you add up all the numbers here and divide it by the sample size. In this case, it is 40. So you add up all the numbers and you get 66.3. That is the mean value. And for the group B here, you add up all the numbers here and divide it by the sample size. And in this case, you get 0.45. So that is the mean value of the group B student. Now, if you use these two numbers as the representative to compare these two data, so obviously you see that the group A students have a higher or a larger mean value than the group B students. So in this sense, we say that the group A students are performing better than the group B students. Now, so this way of doing the mean, of course, there are some advantages. The advantage, one of them, I think is very important, is that it involves all the numbers in the in the sample. It involves all the numbers. So when you involve all the numbers in the sample, it means that you are not ignoring any number in the sample. And we say that there is less information loss in this way. And also, you know, the mean value and the average value is, or the average value is the most popular way of estimating the central tendency of your data. But let's think about some of the disadvantage. Now, the first disadvantage I would say is that it is more difficult to calculate compared with what I am going to tell you on the next few pages. But with the computer, this is not really a big problem. But I think the most important problem is that the mean value can be easily affected by extreme numbers. Now let's look at the example here that I put in the middle. So suppose that we are talking about, you try to ask the income of your respondents. So for simplicity, let's say we only have 3 respondents, like ABC. You ask them about their income. So the first one tells you that, okay, I am making 10,000 per month. So you put 10K here. The second one tells you that I am making 20,000 per month. So 20K here. The third one is the son of Jack Ma, and he tells you that, okay, I am making not too much. I'm making just 270,000 per month. Okay, so and then you try to find the average value of these 3 numbers, and obviously the sum of them is 300,000, and you divide this number by your sample size, which is only 3 in this case, and then you get 100K. So your conclusion is that, okay, these people, the average income is 100,000. Okay, do you think this is a good way to estimate the central tendency of the data? No, why not? Let's say I am this person. I am only making 10,000 per month, and then you tell me, okay, well, the average income is 100,000. But I would say, well, how come I am only making 10,000 per month? How come the average is 100,000? Yeah. So one of you suggests that it is being affected by extreme data. Yes. Now, when we say that, okay, that is a good point. It doesn't reflect the general. Okay, this one I have to give you a like. When we say that we have the average of something, what we usually imagine is something like this. Okay, we say, okay, the average is 100,000. Then what we usually imagine is that most people in the data set will to this sample average value. So our imagination would be usually something like, okay, someone is making 85,000, someone is making 90,000, okay, or maybe 110, 113, and so forth. So all these numbers in our imagination, we think that they have to be around the average value. Okay, that is our impression. And that is the way that, in this way, we think that the average value is a good representative of the other numbers, because the other numbers, they may not equal to the average value, but they are still close to the average value. But in this case, this is not what we expect. We think that the mean is 100,000, so everyone should be around 100,000. But in fact, none of it is near 100,000. One of them is very high, the other two are very low, and it just happens that when we find the average, the extremely low values and the extremely high values, they come up with something in the middle of the data set as the average value, but this average value is far away from any one of them. So in this case, we will not say that this average value is a good representative of the data set, okay? Or in this case, it will be misleading if you report or summarize your data like this. Okay, that is the problem of the average value. Okay, so how to solve the problem? So that's why we have another one, which is the median, the 中位数. Now the median is the number in the middle. Now in this case, we look at data set in group A. These numbers have already been sorted in ascending order. So the smallest number is here, the largest number is here, and then we find the number in the middle. Now there are two numbers in the middle in this case, and we try to find the midpoint between these two values, which means we add them up together and then divide them the total by 2, and that is 67. That is the median value of the group A students. Now, for the group B students, we calculate the median value, and this one is 45. So if you compare the median value of these two data sets, you see that group A students still has a higher score than the group B students. Okay, so that is the median. Now, one very important advantage of the median over the mean is that it is not affected by the extreme values. Now, look at the example in the front on the previous page. Now, for these three numbers here, the median will be 20,000. So although we have some extreme value here, 270,000, the median value here is still a relatively good representative of the data because these two numbers here are close to the median value. Now, of course, I have a very small data set. If we have a larger data set like this, you see that now, even though I may have some extreme values here, like if the 97 becomes something really, really big, like becomes 97,000, the median of the data set is still the same number, 67, because no matter what numbers we have here, these numbers are not taken into account in the calculation of median. As you see, only these two numbers are shaded in black, and all the other numbers are ignored. Okay, so this is how we calculate the median. So the pros here is that one of them is that it is not affected by extreme values, and also obviously it involves less calculation because we only take into account the two numbers. Now, of course, you have to sort all the numbers first from ascending in the ascending order, and then you have to pick the two number or the one number in the middle. And when there are two numbers, then you have to find the average of them. So that is the calculation. But compared to the average, we need to do much less calculation. Now, but on the other hand, if you compare it with the mean value again, because most of the numbers are not taken into account in the calculation, this is both a good thing and a bad thing. This is good thing if there are extreme values and you want to ignore the extreme values, but this is a bad thing if you want to include as much information as possible. But for the median here, we are losing a lot of information because we don't know anything other than the number in the middle. Okay, and of course, you also need to sort the numbers and count the numbers, although this is not a big problem when you do it in the computer. Okay, so this is the median. Now, let me ask you another question. What kind of data you think is more suitable for the mean calculation, and what other kind of data you think is more suitable for median calculation? In what situation would you use the median, and in what situation will you use the mean? Can you give me some ideas? if there are no extreme data, okay, in what type of data do not usually have extreme data? And what type of data do usually have extreme data? Can you give me some example? Now look at the exam score, for example. The exam score, let's say you go from 0 to 100, and then the range is only from 0 to 100, and the maximum difference will be 100. Let's say you score 0 marks and your classmate scored 100 marks, so the maximum difference can only be 100. Now in this case, we do not usually use the median, because although of course there can still be some cool score very high, much higher than the rest of the class, but the difference, although the difference might be a little bit extreme, but still not very extreme. But look at the salary as you suggest. The salary could be very extreme, right? Because there is virtually no upper bound of the salary. So that's why when you look at the statistical reports published by the government, when they describe the income of people, they usually use the median to represent the central tendency rather than, or in addition to, the mean of the income. For numbers like the income with virtually no upper bound, we usually try the median instead of the average, or at least we report both of them. So this is one consideration that you have to take into account when you report your data. Okay, the mean value does not always work. Okay, another one, you suggest a height, the weight normally without extreme data. Yes, that is also the case, because of course, virtually people, the height and the weight, these numbers, some people can be very large, but usually they will not be too far away from other people. So in this case, we usually also do the average value, but not the median value. But for data like the income, we usually use the median. So it shows you that sometimes you have to make your own judgment to decide whether you want to report the median of your numbers or not. Sometimes you have to report the median because the mean value might be misleading. So this is very important thing for you to consider. All right. Okay, and the next one, the mode. Now, one of you also mentioned the mode. Now, by definition, the mode is the most frequently occurring number. So in the group A here, we look at the frequency of each of the numbers, and it happens that the number 78 appears 3 times in our data set. So obviously, if I ask you which one has the highest frequency, then 78 is the highest frequency. And if we look at the group B data, the highest frequency is 44. So we say that, okay, by comparing the mode of the data set, we say that the group A students, they have a larger mode than the group B students. Now for the histogram here, in this case, the histogram on the right-hand side, histogram is we are trying to group these data together into different intervals rather than drawing the frequency of each of the individual numbers. And in this case, the mode or the mode of the intervals, okay, in this case, is the one with the tallest column. Okay, so this is for the grouped data. And for this one, calculation here is for individual numbers. Now, let's look at the pros and cons of the mode. The pros is that it is easy to find because you just need to count the frequencies, and there is even no need to sort or calculate anything. You don't really need to sort the numbers in order to find the mode. And also it is not not affected by the extreme values on both ends. So no matter what, even if you are 97,000, as far as the frequency is not higher than the frequency of 78, the mode is still 78. So in this sense, the mode is also not very much affected by the extreme values. Now, but the problems are that, first of all, you look at the data here and you think, well, there is only one mode. But what if this number here, this is 74, but what if it happens that this is 77? So 77 also has a frequency of 3. Now, in this case, there are more than one mode possible. And also, if the data are evenly distributed. Evenly distributed means that each of the numbers, the frequency is more or less the same for all the numbers. Now, let's say if all the numbers are different, so each of the numbers has a frequency of 1, and 1 is already the highest frequency. And in this case, every number here is a mode of the distribution. But if every number here is a mode, then it means that the mode itself has no meaning because it does not represent the center of the distribution in any sense. So if we have an even distribution, that means when the distribution looks very flat, then the mode here has no meaning at all. And also, since we are only looking at the number with the higher frequency, now the same thing happens here. There could be a lot of information loss. And in fact, that is something like if you can ignore the extreme values, it means that you lose a lot of information. The information, of course, include the extreme value, which I really want to drop it, but it also ignores other numbers in the data set. So sometimes it is not a good way to represent the central tendency of your data. Okay, so that is the third type of central tendency. Now let's put all of them together. Now for the group A, the distribution in A, okay, the mean value is 66.3, which is very close to the median value. And the mode here, it is a little bit larger, but it is still relatively close to these two numbers. So you put this into the histogram here, and then you see that these two numbers, basically, they if you draw them in a histogram, they essentially like the same straight line. And the mode here is a little bit larger. Now for the distribution B here, the mean value is 44.45, which is very close to the median and also the mode here. So you draw them into the diagram and you see that basically they are on the same line. For group B, it doesn't matter which one you use, but for group A, the choice will make some difference. But anyway, using either of these central tendency quantities, you can still conclude that the group A students are performing better than the group B students in this particular case. Okay, so this is the central tendency. And we use the central tendency because we want to represent the position of the distribution using one number. And that one number is what we call the summary of the data. We want to show where the distribution is, and then we use one number to represent the data. And what if the mode is the extreme number? Yes, that is also a problem here. Now, let's say in this case, suppose that we have an extreme number which is 976 7,000, and we have this number appearing 4 times, like this. So suppose that we have these 4 numbers at the end of the distribution, that is the extreme value. And this extreme value, it also happens that the frequency of this extreme value is higher than the frequency of any of the other numbers. Then in this case, the mode will be the extreme value, and it will be actually is it really not representing the numbers? I would say yes, because all the other numbers here, they have much lower frequency. But if your aim is to show which number is the most frequent, then the mode here still give you some insight. But it is not a good representative of the other numbers in the data set. And so it means that you have to actually, when you use one number to represent your data set, you cannot just look at that number. You have to look at the distribution and make a judgment by yourself whether the number is a good representative of the data set or not. So look at the distribution, not only the number. Okay, very good question. Thank you. Any other question about this, about central tendency? Good, thank you. Okay, so let's move on. Okay, now I want to talk about another one, which is the dispersion. Now, dispersion means that now we do not care about the position of the distribution, but we care about the width of the distribution. Now, to see what we mean, let's look at the other 2 data sets here. By the way, what I am going to tell you here, I am going to introduce the variance and the standard deviation. Again, I'm sure that all of you have heard about these 2 values, but I want to tell you what it really means when we calculate the standard deviation. And by the way, both of these numbers can only be applied to scale level of measurement, but not the others. Okay, now let's look at these 2 data sets. Again, can you tell me the difference between the 2 data sets by looking at the data or by looking at the histogram? What is the major difference between them? It looks like the midpoint or the central tendency of these 2 distributions is similar. Yeah, one of you suggests that the range. So by range, you mean the width of the data set, or a more mathematically strict definition of the range is that you find the difference between the maximum value and the minimum value. So you look at these 2 distributions. For group C data, the smallest number is 41. The largest number is 56. So you draw this on the histogram and you see that we only have 2 columns, and both of the columns are between 40 and 60. So you only have 2 of them. But you look at the group D students, the smallest one is 15, but the largest one is 82. And so the distribution looks like this. It is much, much wider. So again, sometimes we do not care about the center, but we care about the width of the distribution. And in this case, we know group C students, obviously, they are more focused in the center. And for the group D students, we have a much wider distribution. So again, the same problem. How can we use some numbers to represent the width of the distribution? The range that one of you suggests is one of them. Now, but let's look at this definition here. Or look at this diagram here. Now, the problem is, how do we define the width of the distribution? Again, there are many ways to do it. So one way is to find the distance between the smallest one and the largest one. So this is the range that you suggest. Okay, but what would be the possible problem of calculating the width using the range like this? What would be the possible problem? Any idea? Yeah, of course, that is easy to calculate, but is there any problem doing it this way? Cannot show the most frequency occurring number. Yes, but we don't care in this case because we only care about the width of the distribution. To show the most frequently used number or occurring number, you can simply calculate the mode that is about the central tendency. But here is not our concern. The grouping, what do you mean by the grouping? Can be 0 to 10, 10 to, so different ways to group the interval. Yeah, but if you look at the number, you still have the same minimum and the maximum, and you calculate the range using the maximum minus the minimum, you still get the same number. Okay, it includes the smallest number, even only representing one student. Yes, but again, we are talking about, okay, you have a point here. Now, to show the problem of using the range to do the calculation, let's look at page 15 here. Now, the range, by definition, it is just the largest one minus the smallest one. So the range here is, in this case, is 56 minus 41, which is 15 for group C. And for group D, it is 67. Now, of course, it is quite easy to calculate, but the problem, again, we look at it in terms of information loss. What numbers are you using in your calculation? You are only using these two numbers. And as one of you pointed out a few minutes ago, if the number that is involved is an extreme value, then that can be a problem. Now, suppose that for this distribution here, suppose that the last one is not 56, but some very large number, let's say 56,000. Then what would be the range because of this one? The range will be suddenly, it will become very large because this number involved here is very large. Now, in the distribution here, it is like, okay, all the other numbers are here, but one number is very large on the right-hand side, so far away that it is on the other screen. And if it is so far away, no matter even though we have nothing between the extreme value and the other numbers in the middle, the range value will still give you a very large number because the range only cares about the maximum and the minimum. And it doesn't matter what numbers you have in the middle. So the extreme value will make the range very large. And that does not really represent the range of most of the numbers in the data set. So that is a problem. That is a problem, easily affected by extreme numbers. So again, sometimes if there could be extreme numbers in your data set, then the range is very problematic. All right. Now, so what do we do to solve this problem? Okay, compare the standard deviation. Yes, so a more common way is to find the standard deviation. In fact, that is almost the standard of doing it. So that's why the name standard deviation. Now, but to understand the standard deviation, we need to first understand the variance. Now, but before that, let me show you some very terrible formula like this. Have you seen something like this before? It looks quite creepy. And you know what? I teach statistics in another institution. And in the statistic course, I actually ask them to do the standard deviation, not in a computer, but by hand. And many of them find it very painful. But in fact, the reason why I ask them to do it by hand is that I want them to really understand what it means by the standard deviation. Now, in practice, we never calculate the standard deviation by hand when we do the data analysis for our research. Nobody will do that. We always use the computer to do the calculation. But it is also important to understand what it means by the standard deviation, because if you don't understand the meaning, then you don't know why you are using it, or you don't know the implication of this number. So what I want to tell you now is to explain to you the meaning of the standard deviation. And to do that, we need to understand the variance first. Now, basically, the variance is some way find the dispersion of your data set, and this way will involve all the numbers in your calculation. Okay, now the principle goes like this. First of all, we have the data set, and then we try to find out the midpoint or the center of the data set. And in the case of the variance, we always use the mean value to find the central tendency. So let's look at here. Suppose that we have the data set with the mean value of 50 here. So we draw a vertical line here in the number line. Now, some numbers for sure will be smaller than the mean value, like the 48 here, it is smaller than the mean value. But some other numbers will be larger than the mean value, just like the 54 here and the 55 here. So we want to find out how far away these numbers are from the mean value. And the reason why we want to do that is the following. Now look at these two diagrams here. If the distribution is relatively concentrated near the mean value, like this one, then you can expect that most of the numbers will be quite close to the average value, like this. Okay, so the blue dot here represents one data point in your distribution, and this is the distance between this data point and the center. And we have another blue dot here, and we have another distance. But all these distances are relatively small because all the data are relatively close to the average value. But look at the one on the right-hand side. Now, this distribution is obviously much more dispersive. And you look at the data point, of course, there are still some numbers that are close to the average value, like this one and this one. But there are also other numbers that are relatively far away from the center. So like this one and this one. So by comparing these two diagrams, it is easy to conclude that the one on the right-hand side, for the one on the right-hand side, on average, the distance between the data point and the center will be larger on the right-hand side than the distance between the data points and the center on the left-hand side. Because on the right-hand side, we have some numbers that are very far away from the center, but on the left-hand side, all the numbers are relatively close to the center. Okay, so that is the idea behind the variance. Now you see that in this case, all the numbers are involved in the calculation, and we try to find out the average distance of these numbers from their center. That is the idea. Okay, but there is one problem doing that. Now look at the next page. So the problem is that, okay, we look at all the numbers, and for the first, we first calculate the mean value. So in this case, we add them up together, divide by sample size, and that gives you 50. And then we try to find out the distance. So we have a 41 here, 41 here. The distance between 41 and 50, you find the difference by doing the subtraction here. And the answer is -9. Minus here means that this data point is on the left-hand side of the mean value. Just like the 48 here, it is on the left-hand side. And when it is on the left-hand side, we put a negative sign in front of it. Okay, for the second one, we have 44 here. We find the distance between 44 and the 50 here, and that is -6. Again, this is negative number, which means that it is on the left-hand side, and so forth. But of course, there will be some numbers that are on the right-hand side of the mean value, like this 56 here. 56 minus 50 give you +6. So altogether, you have 40 numbers like this. And then you try to find the average of these 40 numbers, because you want to know on average how far the data points are from the center. So you find the average of these differences, okay, or the mean value of these differences. Now, the problem is that if you really do the calculation, you will find that they always give you 0. Can you tell me why they will give you 0? Any suggestion why they always give you 0? Now, if you don't believe me, you can simply find you write down any small data set, like with only 3 numbers or 4 numbers, and then you find the average and try to find the difference. Yeah, positive and negative numbers, they will cancel out. And in fact, mathematically, you can prove that they will always cancel out. This is not a coincidence, because you are using the average as your center, and you find the distance between those numbers and the average, and you add them up together, and you will always get 0. They will always cancel out each other. Yes, they will always cancel out each other. So it means that you cannot do it this way, right? If you do all the calculation and you end up with an average value of 0, it means that you don't know anything about these distances. So how to avoid this problem? We don't want them to cancel out, so mathematicians have a very smart way to turn all the negative numbers to positive numbers. And that way is to take the square. So you know, any negative number, you take the square. The number is of course larger, but it will also take away the negative sign. So let's redo it. Instead of just adding them together, we take the square of them. So -9, that is the first number here. -9, you take the square, you get +81. -6, you take the square, you get +36, and you add all of these together. Now this time there is no cancel out because all the numbers are positive. So you add them up together and you divide it by 40, and then the average value is 11.15. But this is not the average value of the differences. This is the average value of the square of the differences, because you square all of them when you take the average. Okay, that is, now this number is called the variance. And in Chinese, it is called 方差. 方差, the 方 here means square. Okay, and the symbol for this is sigma square. Sigma square. Okay, so that is the variance. Now, but when you square something that is not the original thing anymore, you square it, it becomes larger. So larger most of the case, most of the time. So what people do is actually, after they calculate the variance, they also try to take the square root of this. And so, okay, let's go a few pages forward. Okay, this is on page 22. So you cannot just use the variance to represent the distance, because when you calculate the variance, you square all of them and the numbers are likely to be larger if the differences are larger than 1. You square them, of course, that is larger. So people also take the square root of the variance, okay, to some kind of cancel out the square effect. And in that case, we take the square root of the variance here, and you get the number that is the standard deviation. Now, so at this point, we can look at the formula here. What we have just done is something like this. For each number here, for each data point, we find the difference between the data point and this is the population mean value. The population mean value. You find a difference, and then you take the square because you don't want them to cancel out when you add them. You take the square, and this symbol means, okay, this symbol means you add them together, and then you divide it by the n here, and that this whole thing inside is the variance. But you also want to take the square root, and this thing, the whole thing here, is called the standard deviation. And to be more specific, this is the population standard deviation. So it means that if your data are population data, then the way to calculate the standard deviation is to do it like this. But you know, in reality, we never have the population data. We always only have the sample data. So there is another slight adjustment to the standard deviation for the case of the sample value. And we call this the sample standard deviation. Now the symbol here are a little bit different, but they mean essentially similar things. This is the data point. This X bar is the sample mean. So you get the sample value, you calculate the mean of them, like the 50 here. This one is X bar if you are talking about the sample value, sample mean. So again, we find a difference, we take the square, add them together, then the only difference here is that you divide it by n minus 1 instead of n. Now, the reason to this, there are some mathematical complications behind that. And I think I cannot just explain it here in a few words, but what I want to let you know is that when you use the computer software, like the SPSS or even in Excel, the default way to calculate the standard deviation is the sample standard deviation. So it means that when you use SPSS to find the standard deviation, it will automatically give you the sample standard deviation. So you don't have to worry about it. Okay, so, and this way is so standard that we call it the standard deviation. Okay, so that is the meaning of this. So the standard deviation, if it is large, it means that on average, the data points are further away from their center. So it means that the distribution is much wider. But if the standard deviation is small, then the distribution is more focused around the center. That is the meaning of the standard deviation. Now, I tell you the principle behind the standard deviation, not because I want you to do everything by hand, but I just want you to understand what it means, which is I want you to learn the meaning behind the formula. And then people would usually try to find some small data set and actually calculate the standard deviation by hand. We do not do this in data analysis, but we do this in order to understand the standard deviation better. So I also suggest that you write down some small data set, like with only a few numbers, like only 2 numbers or 3 numbers, and then you try to calculate the standard deviation, and then you understand it more. And never memorize the formula. It doesn't make any sense to memorize the formula if you have the computer to do it for you, but it makes sense for you to do some simple calculation in order to understand the meaning of these formulas. Okay, so that is the standard deviation. And by the way, let's also look at the pros and cons of the variance and also the standard deviation. The pro is that all the numbers are involved. You see in this calculation, you use all the numbers here in your calculation. So again, you know, when all the numbers are involved, it means that you do not lose a lot of information. But on the other hand, the calculation is actually quite difficult to do. And also to some people, the calculation is quite difficult to understand. And also all the numbers are squared for the variance, so you cannot really compare the mean. So that's why we take the square root to get the standard deviation. Now, let me ask you another question. Is the variance or the standard deviation affected by extreme value? Are they affected by extreme value? Why or why not? Any ideas? So to see if they are affected by extreme value, you consider if some of the numbers become very extreme, and will they affect the result? One of you says yes, and why? And another one says you compare with the mean and it will kind of balance the effect of the extreme value. Now imagine if you have a very extreme value here, if the 56 becomes a very large number, then of course the mean value will also be larger, right? But when the mean value is larger, and for that one, okay, the mean value will be larger here, but this number will also be larger. So there is some kind of balance, although you are still taking into account all the numbers. And of course, the mean value, the extreme values will affect your result. But compare with your other options, such as the range. Compare with the range. This number, this way of calculating the dispersion is less affected by the extreme values, but there is still some effect. Okay, so compare with the other options, I think this is already a very good one. So that's why it is kind of the standard of calculating the dispersion. All right. Okay, so at this point, I have finished the almost finished the lecture. Now let's go through a few more pages. Now, this one is for categorical. Now, categorical data means ordinal and nominal data. So there is a good news and a bad news about the descriptive statistics for categorical data. The bad news is that you do not have a lot of choices when it comes to the descriptive statistics of categorical data. Now, in the front, I mentioned that you can do the median on the ordinal level data. Also, you can do the mode on the ordinal level and the nominal level data. Okay, and in the last part here, I am going to tell you two more ways to do that. Okay, but apart from this, you do not have other choices. So the bad news is that you do not have other choices, or you do not have a lot of choices. And the good news is that you do not have a lot of choices. So it means that you don't have to worry too much about choosing the correct method to do this, because you don't have a lot of choices to choose from. Okay, now let's look at how we do it. Basically, the categorical data, by definition, you cannot sum them and you cannot average them because they are not really numbers. So all those kind of like a standard deviation, the variance, the mean value, all those things are irrelevant here. What you can do here is to find the frequency of the numbers. Now, let's say, look at this example again. I asked, what is your nationality? So one of you might be American, another one may be French, another one may be British. Now, notice that these are not numbers. So we cannot say that just because one of you is American, one of you French, one of you British, and then I say, okay, the average value of this, then on average, you three, on average, you are French. Of course, that is nonsense. Or something like your average gender is 1.7, which is somewhere between male and female, but closer to the female. Of course, that is nonsense. The only thing you can do is to count the frequency, or you can also do the number in the middle, or find the, actually the mode also means some frequency counting. So you don't really have a lot of choices here. So suppose that you are asking people, like this is a Likert scale problem. You ask, iOS is easier to use than Android. How much do you agree with the statement? So you ask people to choose from one of the 5 choices. Now, you cannot find the average of these numbers because they are ordinal, but you can find the frequency table of these options. So you put down the frequencies here. And the usual way that you can describe the frequency table is like the following. So you look at the 2 options here, 1 and 2, which represent disagree. And then you add them together, and then you say, okay, 20 of them disagree or strongly disagree with the statement. And then you compare this with the other 2 options on the other side, the agree side, and you add them together. 22 of them agree or strongly agree with the statement. Or you can also look at the percentage. And then you say, okay, for this case, approximately the same proportion of respondents are on the agree side than on the disagree side. So these 2, they are similar. Now, we do not usually talk too much about the option in the middle, because when someone answers neutral, sometimes it means that they have no opinion on that, or sometimes it means that they do not really have any decision, or they have not any answer on that. Okay, it means that they are actually undecided. So that's why when I write the Likert scale in my own questionnaire, I usually put neutral or undecided rather than just neutral. But anyway, this number, we do not usually analyze or talk too much about the number in the middle, because it doesn't give you any particular stance in this question. And what I usually do is to look at the disagree side and compare it with the agree side. And then I can try to write a few paragraphs to describe people's tendency in this kind of questions. Okay, so that table, but that is for one question or for one variable. Sometimes you want to consider two variables together so that you can find out any of their relationships. Now, in this case here, we have question 1 and question 2. So you ask them about their opinion, and there are only two possible answers, either A or B. And here we have 4 respondents. So the first person here answers A in both of the questions, and the second one answers A in question 1 and B in question 2, and so forth. So we want to find out how many people answer A in question 1 and also answer A in question 2. And then we look at both frequencies, and then we find that, okay, only one of them answer A in both of the tables. So this kind of table is called the cross-tabulation table. And we have data, we have frequency representing the answers in both of the questions. And then we have 2 people who answer A in question 1 and answer B in question 2. We have no one who answers B in question 1 and A in question 2. And finally, we have 1 who answers B in both of the questions. So that is the cross-tabulation. And I will show you more about this in my demonstration. Okay, so at this point, I have finished the lecture part. And then, okay, I got one question. For the Likert scale, what is the difference of the 5 scale and 7 scale on descriptive analysis? Now, 7 scale, of course, you have more options for them to choose from. I think that is good if it is easy for them to distinguish between the options. But you know, in most cases, it is really difficult to distinguish, to use a scale so detailed like that. So I may know that I strongly disagree with something, and then, or I disagree with something. There are only 2 options here when I disagree with it. But if you make it a 7 level, it means that you have 3 options here. And I think for most topics, or for most people, it is really difficult for them to decide which one they want to choose. Now, if it is difficult for them to decide which one they want to choose, then it means that there will be more noise in your data, because they don't really know when they choose, like you have 1, 2, 3, 4, 5, 6, 7. When they choose 2, maybe what they really mean is 3, but they just don't know which one they want to choose, so they just pick one by random. Now, in that case, it will introduce noise into the data. So my preference is that unless you have a strong reason to do so, you should only use a 5 level. 7 level is really difficult to answer for most people. Now, but sometimes, of course, you might have some very well-defined topic that is not too difficult for people to choose from the 7 levels. Then in that case, I think the 7 level Likert scale is also reasonable. It depends on what you are asking and how difficult it is to distinguish between the different answers. All right. Okay, well, a very good question anyway. Thank you. By the way, sometimes if something is really difficult to answer, I have seen people who use 3 level Likert scale. So just a neutral, and then a disagree, and then an agree. Okay, so they not even try to distinguish between agree and strongly agree. And that is reasonable sometimes if it is really difficult to distinguish between the different levels of agreement. Okay. So before I give you a break, I want you to go back to the Kahoot and let's finish some of the other questions. All right, Kahoot. And these questions will be about what I just taught you in the lecture notes. Okay, question number 7. Which of the following measures central tendency? This one should be pretty straightforward. How do you find the center of the distribution? Okay, yes, the median. The median, by definition, it is the number in the middle, and that will tell you the center of the distribution. The standard deviation is the square root of the variance, and both of them are for finding the width of the distribution because they represent, on average, how far the data points are from their center. So this is dispersion, not the central tendency. And the blue one, the range here, the range is the maximum minus the minimum. So this is also the width of the distribution rather than the central tendency. So the answer is the green one here, the median. Okay, median can be calculated for which type of data? Okay, yeah, the median, the prerequisite of doing the median is that you have to be able to sort all your data because you need to find the data, the numbers in the middle. If you cannot sort them, then how can you find the one in the middle? So nominal data here, obviously you cannot find the median. Like if I ask you, what is the median of the gender? Like some of them are female, some of them are male, then what is the median? Obviously, it doesn't make any sense because you do not have to assign number one to female and number two to male. You can do it in another way, like one to male and two to female. So if the numbers themselves are already arbitrary, then how can you sort the numbers and find the number in the middle? It doesn't make any sense to do that. Now, ordinal, there is a particular order to arrange your data. So ordinal, obviously, you can sort them, and then you can find the one in the middle. And the scale data, of course, you can sort them and find the one in the middle. So ordinal and scale, you can use the median. Okay, which of the following is an advantage of the mean over the median and the mode? What is so good about the mean? Okay, now let's look at these options one by one. So less information loss. Of course, that is true because when we calculate the mean, we involve all the numbers in the formula. So it means that we are not ignoring any one of the numbers in the sample. So that is less information loss. So the blue one is true. The red one, easily affected by extreme values. Now, easily affected by extreme values, that is true, but that is not an advantage. So the red one is not the answer. You need to sort and count the numbers. No, you don't need that. To calculate the mean, you simply sum all the numbers and divide by the sample size, and you do not need to sort the numbers or do any counting. So yellow is not true. So the green is not true. So the answer is blue one, less the less information loss. Okay, you are still at the top here. Next one. Which of the following is an advantage of median over the mean and mode? So what is so good about the median? If the mean is already so good, then why do we use the median? Okay, good. So of course, the main reason why we are using the median is that it is not affected by the extreme values. So consider the salary or income example. You have some extreme values in the income data, but you want to ignore them. So you find the numbers in the middle rather than finding the average. So in this way, you can ignore the extreme values. Now, the red one is not true because when you find a median, you need to sort all the numbers and find the numbers in the middle. So you may not need to count them, but you need to sort them. Okay, so the red one is not true. The yellow one, you are losing a lot of information when you find a median because you are only taking into account the number or the numbers in the middle. So everything else is ignored as far as they do not affect the order of the numbers. So there is actually a lot of information loss in the median. So the answer is blue here. Wow, there are 4 Okay, last 3. Which of the following measures dispersion? This one should be simple, I suppose. Yes, obviously, the standard deviation is for measuring dispersions, and all the other 3 are only for central tendency. Okay, last 2 questions. What is the advantage of standard deviation? Again, this is a little bit tricky. So I give you 60 seconds for this one. Now, okay, the F advantage of standard deviation. So let's look at the red one. It can estimate the central tendency of the sample. No, it's not for that. Of course, in the calculation of the standard deviation, you have to calculate the mean value first, and the mean value gives you the central tendency. But for the standard deviation, it will tell you about the dispersion or the width of the distribution, but it will not tell you anything about the central tendency. So the red one is not the answer. The blue one, all the numbers are used in the calculation. Of course, if you look at the formula, first of all, we try to find the average to set that as the center, and that will involve all the numbers. And then we find all the data points and find their distance from the center. So that will also involve all the numbers. So the blue one is true, and it is an advantage. It is not affected by extreme value, of course not, because of course, this is not true because you involve all the numbers. Although it is less affected than the range, but this is still, there is some still impact if you have extreme values. So it is affected by the extreme values. And finally, its formula is simpler than that of the range. I think maybe some of you may think that it is simpler than just subtracting the minimum from the maximum, but I think for most people, this formula is in no way simpler than the range. So this answer is also not true. Okay, the answer is blue one, is the blue one. Okay, the last one. Which of the following statistical method can be used on categorical data? Categorical data, pay attention to that. Categorical means nominal or ordinal. Okay, yes, the cross tabulation is the only thing you can do, because for the mean, of course, you cannot find the mean of the categorical data because those are not really numbers. If you don't have the mean, if you don't have the numbers, you cannot calculate the mean. And if you don't have the mean, you cannot calculate the standard deviation, because the standard deviation is using the mean as the center. And the range relies on maximum minus minimum. So obviously you also cannot find the range here because those are not numbers in the categorical data. So the only thing you can do is the cross tabulation. Okay, so let's see who wins. Okay, the third one, you could. Okay, second one, HL. First one, Alex. Okay, congratulations to all three of you. We let them dance for a while, and let's take a 5 minutes break, and then we come back to do the SPSS demonstration. Okay, thank you. 5 minutes. Hello, everyone. Let's move on. If you are back, please raise your hand in Microsoft Teams. Thank you. Okay, good. So in this session, in the last hour of today's class, I am going to give you a demonstration of SPSS to show you how we exactly use the SPSS to do the descriptive statistics. Now, I guess most of you do not really have SPSS installed at home. So I think I will just give you a demonstration. Now, but anyway, if you have SPSS at home, you can go to Activity 2.2 here and download the demo data. The demo data is what we are going to use in the demonstration. And for the others, you can also click on this link. The supplementary information for SPS, for data analysis in SPSS. And this is the same link that I used last time. And in this link, you can find the detailed procedures of in using SPSS. So last time I already told you how to use the basic functions in SPSS, including how to clean your data using the data editor. And I also show you how to recode your data. So this document can be found here under this link, supplementary information for data analysis in SPSS. So what I'm going to do here is to follow what is written here in the descriptive statistics and show you how we can do some of the most important analysis. Okay, to save my screen space, I will drag this aside to my second screen and I will show you my SPSS here on my Windows machine. Okay, now the first thing I need to do, or if you have SPSS, you can download this data file, demo data, and then you can open it in SPSS. Now this is already an SPSS format data file. So unlike last time, this time you do not need to convert the data file from Excel format. So you just open the file right away. And the data file looks like this. Now, this data file is actually from my real research data. So of course, I have removed some of the sensitive information from the data, but these are my real research data. And I have also cut down the data set a little bit so that we only have 5 variables here. So you can imagine that these are the variables that we have in the questionnaire. So we have only 5 questions in the questionnaire. And all of them are 4-scale Likert scale. 4-scale Likert scale means that we do not have the center option. We don't have the neutral option. We only have strongly agree, and then agree, and then disagree, and strongly disagree. So sometimes people want to disallow the respondents to choose anything in the neutral option. So we skip the one in the middle and we only take 4 level Likert scale. Now, the respondents here, in this data set, we have a large data set here, 708 respondents, and all of them are primary school students, because basically I am doing educational research. So you have a variable here. This is the gender, and we have the class here, and also the grade. The grade means the level of study. So grade 4 means primary 4, and then we have grade 5 and grade 6 as well. So 3 different groups of students. And then we have the answers in the questions 1 to 5. And we also have some scale variables which represent some kind of other characteristics of the respondents. Okay, so we don't have to go into the details of what they mean, but anyway, these are some of the scale variables. Okay, so now let's try to do some simple analysis. Now, the way to do descriptive statistics in SPSS is to go to the Analyze here. And then you find the option Descriptive Statistics. So all, or at least most of the analysis in the descriptive statistics that you can do can be found under this menu. Now, and in fact, I usually use either one of the three of this. The first one is the frequencies. That is the most frequently used option in the descriptive statistics. Sometimes I also use the descriptives. Sometimes I also use the explore. And then for categorical data, I use the crosstab here. Crosstab means cross tabulation that I mentioned in the last part of the lecture notes. Okay, now, but anyway, to do the descriptive statistics, let me remind you that from last time that you can actually click on this button to do some really quick descriptive statistics. So let's say I want to analyze question number 3. So I just click on any one cell under question 3 here, and then I click this button, the Run Descriptive Statistics button, and then in just a few seconds, you get the result. So in this case, you get the descriptive statistics for question 3. Now notice that question 3 is ordinal value. So the mean here does not really give you any meaningful information about the variable. Okay, so we usually ignore the mean here, but the median can be used here because for ordinal data, as I told you, you can find the median of your answer. And of course, you can also find a mode because that only involves counting the frequency. The range here is not meaningful, so we will usually ignore it. And the minimum, maximum here, these are also not very meaningful. Now down here, we have the frequency table. Now, okay, by the way, minimum, maximum, you can still use it too, because you can look at these numbers and then you know which one will be the minimum group that people choose. So let's say if the minimum is 2, then from here, you know that no one choose strongly disagree. So that is also a piece of useful information. Okay, but the range, which gives the difference between these numbers, is meaningless because these are not really numbers. These are just labels. Okay, question number 3 in the down here, we have the frequency table, which shows you how many people choose each of the options. Next to it, we have the percentage, and also we have the valid percent. The last time I told you that sometimes you have missing value in your data set. And the valid percent means that when we calculate the percentage, we will ignore all the missing values and only divide by the total number of valid cases rather than all the cases, because some of them will be invalid with missing values. So the valid percent can be different from the percent here, but here we both of them are the same because we do not have missing value in this data set. Now on the right-hand side, far right-hand side, we have the cumulative percentage, which means that you add up the numbers one by one, and the last one must be equal to 100, or otherwise you are in trouble. Okay, so this is the quick analysis, but this is not very flexible because there is no way for us to choose what type of quantities we want to calculate. So usually, instead of using this button, we will use something from the Analyze. Oh, by the way, one more thing I want to tell you before I move on. You look at the data set here, and you look at the variable view, so you see that I have set the name of the variables, the corresponding level of measurement. And one thing I did not emphasize last time was the values here. So, sometimes you want to show the, okay, you want to put your data in terms of numbers. Like for gender, you use 1 for the male and 2 for the female. But sometimes it might be difficult for you to remember which gender each number represents. So it is also a good practice in SPSS to put down the labels of the values. And you do it by going to the values here and click on this box, click on the button here on the right-hand side, and then you try to enter the label for each of the values. So in this case, 1 means male. So I put the 1 here in the value, and then I put the label, the M here, as the label so that SPSS knows that the number 1 means the male and the number 2 means the female. Okay, and the same is true for the Likert scale here. I click on this button. So inside here, I actually put down the values and labels corresponding to each of the values. And now you may ask, okay, apart from here, okay, what is the use of putting down the labels? The answer is that at the toolbar here, you find this button. This is called the value labels. And if you click on the value labels, you see the labels that I put into each of the variables will now show up in the data set here. So instead of 1, 2, 3, 4, I get agree, disagree, and so forth. Now, internally, they are still numbers, but SPSS is showing you not the values, but the labels representing the values. So this can be quite convenient sometimes. If you click on this button again, it will show you the value again. You click on it again, and then it will show you the label. So this feature is quite useful. And I recommend that all of you, after you clean your data, you also put this kind of labels into your data set so that you can see the meaning behind the numbers. Okay, so now let's run some descriptive statistics. Now, the way to do it is to go to the Analyze, go to Descriptive Statistics, and let's choose the Frequencies option. Now, most of the SPSS dialogues look like this. You have something, all the variables on the left-hand side, and then you have the variables on the right-hand side. Now, if you think that it is too small, you can make it larger so that you can see all the names and labels of all the variables. Okay, so, and then we choose the variables that we want to analyze and put them onto the right-hand side. The case number do not usually go to the right-hand side because we never analyze the case number. And let's click the gender here. And then we select all the variables. And I do this by pressing and holding the Shift key on my keyboard. Okay, so I click the gender first, and then I press and hold the Shift key on the keyboard, and then I click the next one. And in this way, I will select all the variables except the case number. Then I put these to the right-hand side by clicking on the right arrow button here so that they are on the right-hand side. Now, down here, you can choose to display the frequency tables. So we put a tick here, and that is the default value actually. And on the right-hand side, we can do some more settings. We click on the statistics button. So in the statistics button here, inside this dialog, you see some names that I hope you are familiar with these by now. The central tendency is here. The dispersion is here. Now, on the right-hand side, we also have other quantities, and also here we have percentile, but we will ignore them for a moment, and let's just click the central tendency, median, the mode. Okay, so these three are the most common ones. And let's also do the standard deviation, variance, minimum, maximum, and also the range. Now I choose all of them and I click continue. Now you can also click the charts button, and in here you can choose the different charts that you want to show. Okay, so let's choose pie chart, and then I click continue. Now the other buttons are not very important here, so I will ignore them for the moment, so just for simplicity, and then I click OK. So that will take some time, but not too long. And okay, if you look at the status bar here, you see it is run. By the way, let me show you the magnifier so that it's easier to read. Okay, in the lower right-hand corner here, you see the running frequencies, and then after a while, you get the tables and also the charts. Now let's look at them. Okay, it begins here. This is running the frequencies procedure. Now, before we had graphical interface of SPSS. SPSS was actually just a simple window, or actually a simple console. We call it a terminal. A terminal means that basically there's no graphical use, and you get a command prompt for you to enter some commands. So this is the original SPSS command that begins with the word frequency. Frequencies is the name of the procedure that we are using here. And then we specify the variables. Here we are analyzing the gender, the class, the grade, and so forth. So these are the variables. And then we also specify the statistics that we want to include, and also the charts, like the bar chart, the frequency table, and also the order. Okay, so we go down here, and this is the result. Now notice that we have set the different levels of measurement of the data in this case, but since we are asking SPSS to find the mean value, the median, the mode, and so forth, we specify that we need all these things. So SPSS is actually doing calculation on all of them. So that's why you get a mean gender of 1.47. Now, of course, just because it gives you the number doesn't mean that you should report the numbers. Many students from the past, they simply copy and paste everything given by SPSS and put them into the report. But from here, you see that you should never do that. Instead, you should look at your data, your variables one by one, and you need to decide whether you want to report that number or not. So for gender, because it is nominal value, then obviously you should not report the mean value. And for Q1 to Q5, these are ordinal data, so obviously you should not report the mean value. Now for the last three variables, I have put down labels into the variable editor. So they actually mean creative thinking, critical thinking, and problem solving respectively. Now these are scale variables, so it makes sense to report the mean value and standard deviation and so forth. So be very careful to choose the numbers that should be reported and ignore or skip those numbers that should not be reported in your report. Now, the frequency table. Now, for the frequency table here, SPSS is showing the frequency table of the gender, the class here, the grade here, so you see how many people are in each of the grades. Now, and we also have the frequency from Q1 to Q5. Now, remember that when I report the categorical data like this, we usually report the frequency table, and then we try to compare the percentage of the two options on the disagree side with the percentage of the two options on the agree side. So this is how we do it. Now, for example, if we look at Q3 here, you look at the percentage. So for Q3 here, the first two options, the disagree side, actually you add up the numbers, they give you 57 point something, 87 point something percent. That is very high percentage, right? So 87% of people either strongly disagree or disagree with the statement in Q3. So this is some type of answer that you should report and try to explain this result in your report. And the reason is that this is obviously some kind of tendency in the people's answers. So in your report, you try to explain what it means to your research. How would this answer your research question? And you try to find some literature to compare with your result, or maybe you look into the literature to look for some explanation, or at least possible explanation to this result. So this is how you report your data. Now down here, we have something that is not very meaningful. Creative thinking here. Now creative thinking is a scale variable. And for scale variable, because you see many of the numbers might be different from each other. So you look at this, you have 1.25 and the frequency is 1, 1.38 and the frequency is also is 3. And here we have other numbers. And we have many relatively high frequency because we have a very large sample size. But in general, we do not report the frequency table of scale level data. That is not really a meaningful thing to do. Okay, so I would usually not report something like this or this. The frequency tables are too long. Okay, now, and then we have some bar charts. Bar chart here, we have the gender, and we know how many male and how many female. Now, for this simple data, we do not usually report the bar chart. Of course, you can do that, but we don't usually do that because you already have the frequency table above it. And it is not very helpful for you to plot this bar chart as well. But when is the bar chart helpful? The bar chart is helpful when you want to look at something like this. Now look at the Q1 and 2. From Q1 here, of course, you can also look at the frequency table and look at all the numbers, but sometimes you look at the bar chart and the bar chart will help you look at the overall trend in the answer. So Q1 here, it seems that the answers are more balanced, but already it looks like more than half of the people tend to disagree with the statement in Q1. And then if you look at Q3, you get an even clearer message in here. So of course, we have looked at the numbers in the frequency table, and you know about 87% of people strongly disagree or disagree with the statement in Q3. That is from the frequency table. But look at the bar chart here. The bar chart here also, it gives you an even clearer message because anyone who looks at this chart already know that most people tend to disagree or strongly disagree with the statement, and the agree and the strongly agree on the right hand side. Okay, the percentage is much smaller. Okay, so the bar chart can be helpful here. And you scroll down, you see a few more bar charts. Okay, Now, creative thinking. Creative thinking is scale data. And notice that for scale data, we do not do the bar chart. So this chart, technically speaking, of course, this is a correct bar chart, but this is not appropriate for scale level data. And the reason why it is not appropriate is that you look at the horizontal axis here, and okay, we have 1.25 in the data, and then 1.38, another one, and then 1.50. And the bar chart shows you the frequency of each of the numbers. But the problem is that for continuous numbers like this, or for for the scale level of measurement like this, we want the horizontal axis to be continuous, and each of these bars are equally spaced. But you look at the numbers here, 1.25 and 1.38 and then 1.50, they are not equally spaced. And this could be misleading for scale level data. Okay. So at this point, you see that when we use the frequencies to do these statistics, sometimes the output is good, but sometimes the output could be misleading and even wrong. So a better practice for us to do the data analysis like this is to analyze different types of data separately. So let me go back to this dialog. By the way, to go back to the previous dialog that you have used, of course, you can go to the Analyze here and click Descriptive Statistics and click Frequencies again, but you can also just go to this button. This button is called the Recall Recently Used dialog, and in here, you see all the analysis that you have used before. So I just use frequencies, so I just click on it, go to the frequencies again, and then I get to this table again. Now, if you want to do something more meaningful, let's say this time I want to analyze the scale level data. So you can either click the reset button so that the whole thing will be reset to the default value, and then you can choose your variables again. But you can also just remove the variables that you don't want. I put them back to the left-hand side. And then I don't need the frequency tables for the scale level data, so I remove this tick here. Then I go to the statistics. Okay, these are fine for the scale level data, so I don't change them. And then I go to the charts here. Now, bar chart should never be used on the scale level data, as I have explained to you. For scale level data, we use another type of chart which looks like the bar chart, but actually they mean totally different things. And that is the histogram. So I can go to histogram, and I can also show the normal curve on the histogram. I will tell you what it is when I show you the result. So let's click continue here. Okay, and then we click OK. So this time again, we have the statistics of the 3 scale level variables. And this time, all these numbers are meaningful. The mean is meaningful. And look at here, you see that the students' mean score in the creative thinking is 2.9106. And the mean score in critical thinking is 3 point something, so it's higher. And the problem solving is even higher. So this is what you get from the statistics table here. Now look at the distribution. Now this is the histogram, but not the bar chart. Look at the horizontal axis here. Now all the data points or all the bars are equally spaced. So you have from 1. Of course, some people score very high, okay? And we have some smaller numbers here. And you also see the frequency of each of the intervals. And in fact, SPSS determine the intervals for you. It will just calculate the intervals automatically. And then it also puts down this curve on top of it. And this is the normal distribution curve. And sometimes if we want to know if the data follows a normal distribution, then we put the curve on top of here, and we see if it follows the normal distribution. Okay, now let me ask you, would you think that this is a normal distribution for this data set? Yes or no? Why not? Yeah, for which part? This one, right? This is, I would consider it some kind of extreme value, although it is not very different from the others. Okay, blue bar, all of them are blue bar anyway. But this one, obviously, it does not look very much like the normal distribution. Some students, they score very high marks here. And that is obviously different from the other people. Now, but in statistics, first of all, in statistics, why do we care about the normal distribution? And the reason is that in some of the inferential statistics analysis, we need to choose the method based on whether the distribution is normal or not. And I will show you in the next class, which is in the next week. And but you know, in practice, we never have any real data distribution that is normally distributed. So there is always some discrepancy from the standard normal curve, and like this one. And also we have a little bit higher here, and we have a little bit lower here. Now, but how much discrepancy is considered important? Now, there are some statistical tests to tell you whether a distribution is normally distributed or not, but those tests are usually quite sensitive. Sensitive means that when there is even if there is very small discrepancy like this one, from the normal distribution, the test will still tell you that they are not normally distributed, which is true, of course. But for the practical purpose, if you always require that they pass all the very strict statistical tests in order to consider it as normal distribution, then in most of the cases, you will not have normal distribution. And my opinion is that that is not a very practical thing to do. So what I usually do is just to look at the approximate shape. And if we only have something like this, but the sample size is large enough, then I will still consider it a normal distribution. Although obviously, if you do any test, the test will tell you that it is not normally distributed. But you look at the distribution here, and for most purposes, if you have a large sample size, like 708, in this case, I would still consider it a normal distribution. And I will tell you more about that in the next class when we talk about inferential statistics. Okay, anyway, the histogram tells you the distribution of the data set. As I told you, sometimes it might not be enough to just look at one number. Like you look at the central tendency, like the mean, the median, what is going on behind that. So I would usually also look at the distribution of the numbers so that I know what these numbers look like, okay, to have a better idea of how they distribute rather than just look at the mean value or the median value. Okay, anyway, in this way, you can analyze do the descriptive statistics for your data. Now, let's do another way. Now, in the analyze here, you can also do the descriptive statistics and then the descriptives. Now let's click on this one. So again, I need to put some numbers, values on the right-hand side. So let's, for simplicity, let's just put the creative thinking. Now you see this descriptive dialog is not the same as the frequencies dialog. For example, on the right-hand side, you only have 3 buttons here. And if you click on the options, inside you can choose what type of quantities you want to show, but you do not have as many options as you do in the frequencies dialog. Now, in fact, the reason is that SPSS is not like many different people are working on the SPSS, and it turns out that the different people try to write some procedures to do different types of analysis. So the frequencies is one procedure, and the descriptives here is another procedure. But these are written by different people or different groups of people. So when they do it, some of these procedures have some overlapping. Like in this case, both of them can calculate the mean and also can calculate the standard deviation and so forth. But the interface looks a little bit different because they do not really communicate with each other to make sure that everything is consistent. They just work on it separately and put the procedures into the menu for you to choose from. So there is some overlapping. Now let's click the continue here and click OK here to see the result. Now in this case, you see this statement. This is the command. Descriptive is the name of the procedure. And we specify the variable by using variables equal, and then we put the variables here. Now, compare this with the one that we just used. Okay, the frequencies. Okay, the name of the procedure is put here, and then we use variables, and then we put the name of the variables here. And then we have the format, and we show what statistics we want to do. Now for the descriptives here, we also have similar options, okay, to do the different statistics here. Now, but the format of the resulting table is different. Now look at here again. For the frequencies procedure, the variables are here in the column, and we have all the quantities here. But for the descriptives here, the variables are in the row, and the values here are in the column. This is another example of the inconsistent design between the different procedures. And again, that is because different people work on these different procedures. Now, but there is one way for you to change the way that you want to show your result. The way to do it is you go to the table here. You can actually double click on the table. Now, when you double click on the table, it looks like the table is selected. And then if you right click in the table, you can go to the second last option that is called the pivoting trace. Sometimes this option will pop up automatically, but if it does not, then you just right click and choose it from here. So if I choose pivoting trace, you get a menu, a dialog like this. Now, this is very interesting. This is the place for you to choose how you want to arrange the result. So if I go to variables here, I can click on it, and then I can drag it to the columns here. You see, when I do this, the table already changes its shape. And then I go to do the statistics. I drag the statistics to the row. You see that the quantities or the statistics are now on the different rows. And vertically, we have the variables. So this is the way you change the arrangement of the tables. Now, after you do it, you can close this dialog. Now, but sometimes you may not want to show everything in your table. Now, in that case, you can go to the column or the cells that you don't want. So let's say I don't want to show this column. So what we do is to go to here, and then I click the Shift button to highlight the whole column. And then I just press the Delete key on the keyboard, and then that column is gone. So this is quite convenient feature to modify the table. Now, if you are done with your editing, you just click else anywhere else so that to go back to the output. Now, and then the next thing to do is, you basically you do your report in Microsoft Word or other word processor. So how do you get this table into Microsoft Word? Now, it turns out that it is extremely easy to do it. You simply right-click, copy, and then you have your Microsoft Word report. So let's say I create a new file here. I have copied that table, and then I just paste the table by Control-V, or you can just click the button here. Now, notice that the table, when it is pasted into the Microsoft Word, it is still a table. So it means that you can use the table tools in the Microsoft Word to edit the table or to change the way that you want to display the tables. Okay, so that is also very convenient. So you can even change the names here, like you can change it to sample size or anything else that you want to use here. Okay, so that is how you output the tables. Now, but you may also want to output the charts. Let's say we have this chart here, and we want to put this chart into my report. So what I do is to right-click again, copy, go to the Word here, and then I paste this chart. Now, but notice that while the table is still a table in Microsoft Word, when you paste the chart, this chart itself, it becomes a picture. So you cannot edit the picture in the Microsoft Word. And except for adjusting the border style, adjusting the the color like this, okay, the correction, the brightness, and the contrast, and so forth. But you cannot change the elements inside the chart. Now, if you want to change the elements inside the chart, you need to do it in the output window in the SPSS. So for example, if I want to change this chart, then what you do is to double click on this chart, and then you see the chart editor. Now, let's say I want to change the number of intervals. I don't want so many groups. I only want to have a few groups. So double click on here again, and then you will get the properties dialog. And in the properties dialog, one of the options is called the binning. The binning here means how you are going to divide your data set into different intervals. So if you want fewer intervals, then you can go to the x-axis here, go to the custom. The original setting is automatic, but I want to do my own setting here. Let's say I only want 6 intervals. So I put a 6 here, and I click apply. You see this looks very different now. And originally, we have a very high frequency in the front, but after redefining your interval, it looks more like normal distribution. And this is the way you cheat your supervisor to make your data look like normally distributed. But just kidding, do not do that. But anyway, you change the number of intervals, and then it will look a little bit, it will look different. Now, if you want to change the color, then you can go to here. Like you want to choose a different color, like the red one, then you apply it, and then you will change the color, and so forth. So there are a lot of options here that you can use, but I will let you explore it by yourself. Now, after you do your editing, you can close the chart here again to go back to the output viewer. From here, you can copy and paste your new chart into your report. So that is how you export your data. Very convenient, actually. Okay, so that is the descriptives. Now, the next one is the explore. We go to analyze again, descriptive statistics, and explore. Now, this time again, the dialog is a little bit different, but for simplicity, let's again just put the creative thinking onto the right-hand side. And I will tell you what it means by factor list in a while. Now, click the statistics here. Now, you know, this time we do not have a lot of options. And if you just want to show the descriptive statistics, you click on here, but you have absolutely no degree of freedom to choose what type of descriptive statistics you want to show. Okay, so this is the way that the explore procedure is written. Now I click continue here. In the plots here, on the right-hand side, you can choose to show the plots. For some reason that I do not really understand, the stem and leaf plot is set as the default. The stem and leaf plot is something very old, and I have never really used this thing in my research. And I learned it many decades ago, and I think that is already quite outdated. So I don't usually choose this one. And instead, I usually do the histogram. Okay, continue here. Okay, so now let's click OK. Now in this, after I click OK, you see that again, I get another table, creative thinking. I get all the quantities, but this time there is really, you cannot really choose what quantity you want to show here, but just follow the default setting and you get all the values here. And also we have the histogram. Now, one thing that I like, one reason that I like the Explore is that you can draw the box plot like this. The box plot basically means it is something like the histogram, except that we are looking it from the top. We are looking from the top. So here in the histogram here, the vertical axis means the values of your data. And the blue box here shows you the range of numbers in the middle 50% of the data set. The numbers in the middle 50%. So it means that 50% or half of your data values fall into this range from 2.5 to here. It looks like 3.25 something, okay? So half of your values are inside this box. And then these two vertical lines here extend to the other values. And sometimes you have some extra points here, and this point represents outlier. So the box plot is good in that if you just want to look at where the middle 50% of your data are, and you also want to identify the outlier, then this is the way you do it. The 297 here is not the data value, it is the case number. So it means that you want to see what it is, and then you go to the data set and find this case. and you can inspect the data by yourself. Now, but the real strength of this explore procedure is not only that. The real strength is that you can try to analyze your data using some grouping. So let's say I want to calculate the creative thinking, but not for everybody as a whole, but I want to compare between the 3 different grades so that I can know if there is any difference. Now, in that case, you pick the variable that will tell you which grade the people belongs to. And in this case, it is the grade variable. I put it in the factor list, and then I click OK. Now, do you see that instead of one single value, I get the mean value for the 3 different groups. Sorry, this is not the mean value. This is the case frequency table. And then down here, we get the statistics for each of the groups. So the mean value here, 3.0394. This is not the mean for everyone. This is the mean only for the grade 4 students. And then we have other statistics, but only for grade 4 students. Then we have another number for grade 5 students and another number for grade 6 students. So this is quite useful if you want to compare between the different groups. And in fact, I usually recommend that you compare between different groups because that might show you something very interesting. And when you find this kind of interesting result, it means that you can write something in the discussion to discuss this to a greater depth, and potentially you will find something, you will be able to write down some very good discussion. Usually. Now, and then in the creative thinking here, okay, I lost the connection. Let me reconnect. Okay. So down here, you also have the histogram, but this histogram is only for grade, and then for grade 5, and then for grade 6. So again, that is good. But the best thing is the box plot. Now, from this box plot, you immediately see the difference between these 3 different groups of people. Now, in fact, by the way, the line here in the middle of the box is the median value. So if you look at the median value, you compare the 3 groups, you already know that the grade 6 students seem to be performing worst in the creative thinking when you compare across the 3 different grades. So again, in your own research, if you find something like this, then you can try to explain the differences and tell the readers what it means to your research question. And that will be a very interesting comparison. Okay, and the explore function here, procedure here, allows you to do something like this. Now, but anyway, if you want to do the other procedures, but you also want to put people into different groups to do the comparison, then there is also a way for you to do it. Okay, what is the black line in the middle? This is the median. The box plot gives you the median in the middle. Yeah. Okay, so if you want to use the other procedures here, but you also want to split the students into different groups, and there is also a way for you to do it if you don't want to use the explore procedure. The way to do it is to go to data here, and down here there is an option called the split file. Now, if you click on the split file here, this is where you can choose to split your data set into the different parts. Like to do that, we click the compare groups. So let's do the same thing. I want to use the grade as a grouping variable. So I put the grade onto the right-hand side. I want to group my data based on the grade. So I put the grouping variable into the right-hand side. And down here, make sure that you choose the first option, or otherwise the grouping will be wrong. Okay, this is very important. Sort the file by grouping variable. Now, of course, by doing this, the ordering of your record might be changed. So that's why it is important to have a case number so that you can revert to the original order. Now I click OK here. Okay, so you see this statement here, sort cases by grade, split file layer by grade. Now, you may not see any change here, except that you go to the lower right-hand corner of the data editor and you will see the split by indicator. Now, in the split by grade indicator, it means that everything you do from now on will be split by grade. So let's do it by repeating the frequencies analysis. So for simplicity, let's only do one of them, the creative thinking. And I just click OK here. So do you see that instead of showing you the mean value of everything, this time we have the mean value for grade 4, mean value for grade 5, and of course, along with other statistics, and also the mean values for grade 6. Okay, so that is another way for you to do your analysis to the multiple groups for multiple comparison, even if you are not using the explore procedure. Now, but remember, every time you do this, once you are finished, you have to remove the grouping. So the way to remove the grouping is to go to data again, go to the split file dialog again. And this time, now you don't have to remove this one. You just need to click the first option again. Analyze all cases, do not create groups. You click OK here. You see another statement called, this one is simple, split file off. And you look at the data editor again, look at the lower right-hand corner. Now this time, you do not see the split by grade anymore. So it means that the splitting has been canceled. All right, so that is how you do the splitting, okay? Compare by groups. Okay, the last thing I want to tell you today, actually the last two things I want to tell you today is, first of all, how we analyze categorical data. Now, to do the categorical data, first of all, you have already learned how to do the frequency table. But now, let's also do the cross-tabulation table. To do the cross-tabulation, we go to the Analyze here. And again, we go to Descriptive Statistics. And we move downward a little bit to find the cross-tab option. Click on this one. Now, for the cross-tab, you need to specify the row variable and the column variable. Now, let's say I want to know the cross-tabulation between the gender and the grade. So I put one of them into the rows and one of them into the columns. Now, in the statistics button here, you can choose a lot of other things. Now, this is the chi-square test, and I will go through the chi-square test in the next class because that belongs to inferential statistics. Now, in the cells here, you can also choose to show the percentage rather than just the frequency. You can show the percentage. And you can choose the row percentage, column percentage, and total percentage, and so forth. But again, for simplicity, let's just keep the default value, and then we click OK. So this is the cross tabulation table. In this table, you see, say, how many people are in grade 4, and at the same time, they are male students. So when you look at this number, it already tells you that, okay, there are 135 of such students. And you look at the other cells here, okay, how many females in grade 5? So you see it is 109. That is very create the cross tabulation table. Okay. Now the last thing I want to do is to show you how to do some other type of graphing. Now you already know how to generate the histogram, how to generate the bar chart, and also the box plot. But what if you want to draw some, do some graphs that are not available in the procedures that I just showed you? And the answer is that you simply have to go to the graphs here and then choose the chart builder. The chart builder is quite straightforward, but anyway, when you use it, it will give you a warning message. Basically, it just tells you that you need to specify all the levels of measurement. But we have already done that, so we can just click OK. So in this dialog, at the bottom here, you see a lot of options, different types of graphs that you can choose from. And then if you want to do any one of them, you simply click on here and click on the type of chart that you want to use, and then you drag it to the middle here. Okay, now this is not the real data. This is just a sample data to show you what the chart looks like. And you have to specify the variables that you want to plot. So let's say I want to create the bar chart for again. So what you do is to click on this one and drag it to the horizontal axis. Release your mouse button, then you just click OK. You see, this is the bar chart. Now, but one very interesting feature about the chart builder is that you can also have a lot of interesting options, like in the basic, in the group and points ID here, you can choose some options like the clustering variable. Okay, in the clustering variable, you can specify that you want to use another variable to separate your bar chart into different groups. So you know, now you've seen how I separate or split the data file into different groups using the split file. But if you want to show the different groups in the chart, you can also set the cluster and put the grouping variable onto the right-hand side, and you click OK. You see, then you get a bar chart of the different genders. Now, similar things can be done by going to the graph here, chart builder, and choose other variables and other graph types, and then you can explore it by yourself. That is really powerful thing to use in your data analysis. Okay, so I think time is up today. So I have already finished what I want to do today. I have talked about the concepts of descriptive statistics. I have talked about how to do the descriptive statistics in SPSS, including the graphing. I also introduced the histogram and the box plot, and also show you how to export the SPSS result to a Word file. So basically, I have gone through everything here. Now, so next time, that is next week, we are going to do the inferential statistics, which will be very difficult for most of you, but it will also be very useful, because most of the time when we do data analysis, we are not really interested in just the sample data. We are more interested in the population data, and we use the sample data to make a guess about the population data. And to do that, we need the inferential statistics. So that will be the topic for the next one. Now, finally, for those of you who came in late, please remember to sign your attendance here. Okay, just for our record. I think that is the end of the session. And thank you very much for coming to here today. And I will download the video and I will post the link to here, and then so that you can refer back to it afterwards. All right, so thank you very much. See you again next week. Thank you. Thank you, bye-bye.